Hello, good day to all the dear students over there. Welcome to my channel Yes I Can Solve. The intention of this channel is I just want to boost the confidence in my students. Yes, you can solve maths and definitely it is not the hardest subject as the people think. So here for the 10th students, what I have done is with each chapter I have sum up in the form of a capsule within some minutes what you will be able to do. Quick revision you will be getting. You will also be getting few important problems. Along with that, if you have any doubts, you can just leave a comment and I would love to solve that questions in the upcoming video. So let us start with our first chapter from our NCERT, that is real numbers. The set of real numbers is denoted by letter R and it contains rational as well as irrational numbers. So what are rational numbers? Rational numbers are those which can be expressed in the form of p by q, where q is not equal to 0. So it includes all our numbers. Like let me first tell example like 3 by 4 and negative 5 by 7, so on. So it includes all the numbers like natural numbers, whole numbers, integers. I like to stress even fractional numbers. So what are fractional numbers? I just want you to have a clear difference between fractional numbers and what is the difference between the rational numbers. So fractional numbers are numbers definitely which can be expressed in the form of p by q, and in fractional numbers the p here is only positive. It cannot be negative as in this case. That is why rational numbers is a bigger set which contains even fractional numbers. That is even the positive as well as negative p is included in our set of rational numbers. And irrational numbers are those which cannot be expressed in the form of p by q. Cannot. Okay. So here like numbers what we have, square root of 2, square root of 3, square root of 5, and our favorite pi, the constant which we use frequently, pi is also an irrational number. So now what? Under the root any number which is not a perfect square, we will be focusing in irrational numbers, or we are the set of irrational numbers contain all the imperfect square numbers. So after knowing this, okay, so the next important thing what we have to learn here is the concept of Euclid's division lemma. We have to learn about Euclid's division lemma. See what is Euclid's division lemma? Before getting into that, let me give you a very easy example. Okay, so our Euclid division lemma. So what we have to learn here? Before getting into that, I want to give you an easy example. Let us take 25 divided by 4. So here what I will be getting? 4 6 24. 1 is the remainder. So what we call for this? This is my divisor. This is quotient. This is dividend. And this is remainder. Okay. So see, if I consider 25 as A and B as divisor, so how I can get back 25? B into Q plus R. And here R is the remainder. Okay. So this is what division lemma of Euclid also states. That is, our divisor will be multiplied by quotient, added to the remainder, we will get back our dividend. And how is our R? R will be greater than or equal to 0 and definitely less than B, right? So this is what is our Euclid's division lemma in a very simple way. So it is having many applications, like we will be able to find the HCF of any two given factors by using Euclid's division lemma. Let us see how to get the HCF of two factors. Okay, I hope you have understood what is Euclid's division lemma. Euclid's division lemma is simple, where A and B are two integers and B. Okay, so once we will have a recap for Euclid's division lemma, where a and b are two positive integers. There exists q and r, again a positive integer, in such a way that a is equal to b times q plus r, where q is between 0 and b. So let us go with the example. So let me just clean it, my dear students. Okay. Okay. Let me give example finding the HCF for two numbers, that is 135 and 225. Okay, this is the example which I have taken from your NCERT exercise. This is one of the exercise question. So which is the smaller number here? Definitely this is considered as B, and the greater number is taken as A. So how I will write? 225 is equal to 135 into 1. Okay, so I am dividing. What will be the remainder? So 225 minus 135, 5 minus 5 is 0, 2 is less, so 12, 12 minus 3 is 9. Okay, see, I'll continue the same thing until I am left with the remainder as 0. So next is what? I have 135. Okay, so here what I will be writing, 90 is my B now. Okay, into 1. Okay, because 90 times 1 is 90, so 135 minus 90 will give me how much? 45. So now again what will happen? A will be 90 and B is 45. So 45 into 2 is 90. So what is my remainder? 0. See, like this, until we get 0, we need to continue the same procedure. So what is my HCF? Is the B in the step, or you can take the previous step, the remainder. So HCF of 225 and 135 is 45. This is how it is easy to find the HCF of two numbers by using Euclid's division lemma. So now we have to learn about the fundamental theorem of arithmetic, that I'll be doing in the next video. So do practice to find the HCF and get back to me with your sweet comments, whether you have understood or not, and even any question which you want me to solve. Take care, dear students. Bye.